Hello everyone. Am I audible? Can I can anyone confirm?
Yeah, Ashish, you are audible.
Yeah. So hello everyone. Uh, First of all, thanks a lot for participating in our event and joining today's session. So there will be a total of two sessions conducted today. Session one will be focused on electronic side of Arduino and its simulations on Autodesk Tinkercad. And the second session will be focused on the coding part. So first session will be taken by Manish Vibhu and second will be taken by Ankit Singh. So over to you, Manish. Before that, is there any questions you guys have? Anything you want to ask regarding hackathon?
Yes, Ashish.
Yeah.
Yeah. Is we needed any kind of particular software downloaded or other on or we
No,
just need the online internet is
the
sufficient.
you won't require anything to download. Okay, so whatever the simulations we will do on Autodesk Tinkercad. It is basically a web-based platform, so you won't need to download anything else. Okay, uh, signing up on Autodesk Tinkercad is also very simple. You can do it with your Google account simply, and nothing else will be required.
Okay, Ashish. Thank you.
Yeah. So I'm supposing that no one has any question. So Manish, you can take over from now.
Okay, thank you, Ashish. Hello, everyone. I hope you all are doing well and very excited for the hackathon. So, I will explain uh, basic part of basic electronic parts, which is the basic electronic components which used for Arduino projects. Let me share my screen. Okay, is my screen is visible? Okay.
Yes.
So there are a lot of electronic components, but here we will basically introduce few few electronics components which needs for this hackathon, mainly this hackathon. Okay. For this hackathon, we will need no any hardware, no any physical component. We'll practice the thing online simulation form. So everyone sign up on that. I will show you. Okay, see the screen. Okay, first of all, search for Tinkercad on Google. Then this is the website for Tinkercad, tinkercad.com. Log in with a student account. You can sign up with any account, like directly log in with Google. Okay, after signing in, you can see the screen, this screen. Here is an option circuits. So click on that option circuit. So you can see this window. If you have made any project uh, previously, then uh, all that's shown here. So here we can take create new circuit. So this is the main area where we can design the circuit, and all components are there. You can take any component and design the circuit here. Okay, so now we will learn the electronic components. So basically we need few of them for the hackathon. If we will go for some advanced prototyping, then we will need more components, but we will learn all the components. Actually we have not that much time to explain all the things in better way, or show the all the practical with this these all components. Okay, but we will cover, I will try to cover all the things. Okay, so LED, the first component, basic component in electronics components is LED. LED is basically a light emitting diode. It has two terminals, one is positive and second is negative. So it is a one-way device. If we will connect to positive terminal to positive supply of battery and negative to negative supply of battery, then only it is work. Yeah. Okay. Okay. No, actually it is PDF form. Okay. So where I okay. When we will connect positive terminal of LED to positive supply of battery and negative terminal to negative supply of battery, then only LED works. Okay. So basic funda is we have to connect the right terminal to right uh, power supply. This is the battery power source. So all these are um, DC DC power source. So if uh, all the project Arduino project work on only on this DC, so we will take a battery uh, or any mobile charger for the Arduino project. So in DC battery, two terminals. First is positive and second is negative. So we have to work according to that. We have to do connections, a perfect connection with perfect terminals. So we can take any battery. Let's see on Tinkercad. Say here two or three batteries are available. It is 9-volt battery. It is coin cell 3-volt battery. It is 1.5 volt battery. So we can take any of them. Like so, for any components to drag on the uh, working area, we have to click on that and just slide, and then click again to paste it. So if we move cursor here, then we can see the positive and negative. So this is the positive terminal and this is negative terminal. We can connect, we can take a LED. So this is the cathode, this is anode. So the cathode is the cathode is here negative terminal and anode is positive terminal. We can take a resistance. Or for connecting, we have to click on that terminal and just drag it and connect to the second terminal. Then click on the terminal, drag it and connect, click on the second terminal, it will connect. So okay, this, so I have connected it is connected it in wrong way. This is the positive terminal, but I have connected it to the negative terminal. So that's why LED is not working. You can see start simulation, not working. So we have to connect it correctly. Just change the terminal. Now see, LED is lighting. Okay. Now move to the second part. Switch. Switch or relay. So we can use switch for interrupting the power supply. Like we have to do, okay, see, like we have to switch off the light, but I cannot switch here, switch off. So that's why we will use switch. So here is two switch, push button and slide switch. So push button switch is basically uh, in that uh, when we have pressed the switch, it will on, and when we will left, it will off. So every time to on the circuit, we have to press the switch. We have to keep pressing, then the circuit is on, and when we'll leave it, it will off. So for continuously switch off and switch on operation, we will take slide switch. So here is three terminal in slide switch. So we can connect first middle terminal to the supply, and we can take either one of them for other terminal. So now see, if the slider is on the left side, it is on, and if the slider is right side, it will off. So the switch, basically working of the switch is interrupting the power supply. It will interrupt the power supply. Okay. Now this is the register. So register is used for basically protect the device. So here you can see I have used a register for the LED, because if we will if 9 volt is directly given to this LED, this LED will damage. Like, see how can it damage? If we will directly connect it to the battery, Now see, here you can see current through the LED is 915 milliampere. Maximum current is 20 milliampere. So LED is damaged here. So this is the online simulation. That's why we can do mistakes. But if we have physical components, then if we do mistakes, the components will damaged and we have to purchase new components. But here we can correct the mistake. So we have to take a LED a register for LED. Okay, now it is working. Okay, move to the next part. So we have to use register for mainly all the sensors LED, so that it will protected. Now potentiometer. Potentiometer is also like a register, but uh, we can control its resistance with its volume by rotating it. We can control the resistance values. So here is that potentiometer. So see the so we will connect the middle terminal to, and we can connect any terminal for the LED. Okay, see the LED is very low. Okay, the light is very low. Now we can rotate it, then it automatically damaged because resistance value is decreased. But here it is okay. So we can control the resistance value by rotating this. Okay, now move to the next part. So diode. Okay guys, wait for a minute.
So sorry for for the disturbance, guys. He's coming in 5 minutes. Wait for 5 minutes. Till then, anyone have any question? Anyone?
Okay, okay, 20 minutes.
Yes, so up to how much resistance we should use to, if we are using resistance instead of potentiometer,
Okay,
then how
okay.
much should we use to, say, connect with the circuit so that the LED can work properly? What should be the,
It depends.
yeah,
It depends on the power source. How
Okay,
much
okay,
power source from power source we are getting.
okay,
So how much we wanna reduce the voltage.
okay.
So
I,
that
I will call
depends
you.
upon how much you wanna do the you wanna create the resistance.
I see, thanks.
Yeah, there's a formula you have given that V is equal to IR. We are,
Yeah, right,
yeah.
right.
So that formula that works on that formula everything. Okay. So you can also calculate on the paper, okay. For first, you wanna how much you wanna resistance you wanna create it, okay. So you simply put the resistance, whatever the resistance you wanna give. There's a you have seen the portal. There's a column where you can put the resistance. Any other questions till now?
So I was saying that can you give us something to do, like till then the money is coming, then till then we can do something.
Yeah, you can simply, first of all, you can go to the Autodesk Tinkercad. Okay, you can go on the website, log in. There you can do, once you get there, you can do a lot of stuffs there, like creating a simple structure like Manish have shown just before, just a few time before. Uh, you can do it now, right now. You can do. Yeah, Shivani, you can go now.
So Sivani, I think potentiometer is works like you can turn it. There is a knob there, right?
Oh, okay, okay. The potentiometer, you can, it is resistance is like a, you're creating an hindrance between, uh, you're, you're trying to reduce it, but with potentiometer you can, whenever you want to increase the voltage, you can do it. By how much you want to do it, you can do it.
Hey, sorry for that.
There's a question in the chat box. You can check it out.
Okay. Okay, so let me explain this. We can uh, change the resistance by sliding the potentiometer. Okay, it is basically used for any vo- in the volume department. Like we have to change the volume of a speaker, etc.
How can we
I
know
make
that how much resistance it's providing right now?
actually it can be calculated. I don't know, but it is not showing. You can calculate it uh, by voltmeter and ammeter. Okay.
Oh, okay, okay.
Also, and resistance value. I think Sahars has asked. Resistance value can in Arduino project we don't need the exact resistance value for anything. We can use for LED and mainly we will use resistance in this hackathon or any Arduino project. So mainly we will use 1k ohm. The value of resistance is 1k ohm. It is sufficient for LED and any sensors. Okay.
So using a wrong register won't damage any equipment, right? It will either
No,
work or
no,
not.
no. It will damage if we use very less resistance. Actually,
Oh, okay,
so
okay. Yeah, makes sense.
like you like see, I will explain you. So see, here is 1k ohm resistance, so it is not damaged. LED don't get damaged. But if we reduce the resistance value to like 50 ohm, 50 ohm, now see, it will get damaged. Okay, so basically we have to use resistance value that can provide less than 20 milliampere current. Okay, so here 200 ohm also work. but it gives some warning. It will also damage the LED. We can use 500 ohm. Now it's perfectly working. So we will actually use the 1 kilo ohm for most of the project. Okay, it will provide the safety to the all the electronics components. Okay, so I move to the next part. So diode is a one-way device. Okay, if we have need any type of one-way power supply, then we use diode. Like it is also like a LED. If we will connect the positive terminal to positive, its cathode to the positive and anode to the negative, then only it will pass the current. Okay, see how it is working. So if we connect the cathode to negative and second, now see it is working because I have connected the cathode to the negative and anode to the positive. So the circuit is operating, and if we interchange the position of diode, then it will not work. Like it rotate. Okay, now anode is connected to the negative terminal and cathode is connected to the now see it is not working. LED is not lighting. So diode is used for basically to protect from wrong connection. Uh, if we mistakenly connect the positive terminal to any device, any negative terminal of device, then it will protect. It won't pass the current through them. So diode is used for a one-way power supply. Now next is transistor. So transistor is a semiconductor device. It is also it means it is mainly used for amplify the electronic signals. It is also used for switching device, but mainly it is used for amplifying the electronic signal. We don't need these components in this hackathon, but let me explain. So okay, I can show. Okay, here I have used a diode. Okay, diode transistor, sorry. So it is mainly I don't know, here all the components is not present, so I cannot show the real operation of diode. Basically it is used for the electronic signals like sound signals, mainly for sensors, uh, uh, some low sensors which detect some low value, so we will amplify the value for with the help of diode, transistor, sorry. These are all.
So,
Yeah,
hello.
okay.
Ravikant, do you have any question to ask?
Yeah, actually, I'm able to get the wire, but when it's getting connected, I'm not able to remove it. I'm not able to the wire. It's
Okay,
getting caught.
just click on it, click on the wire and delete it. Okay, and you can also delete the components in similar way. Click on the component and delete it. Okay, you all will get practical with Ankit Singh from the 9 p.m. I will explaining you some basic. I'm here explaining you some basic components. The basically introduction with the components. Okay, you will get the detailed practical session from the 9 p.m. Um, uh, so the next is capacitor. So capacitor, we will use the capacitor for like okay. So we will use the capacitor for protecting the device from the sudden change of any voltage, current, etc. So it will actually store the power, store the voltage, and it will protect the circuit. Like okay, see the practically. So this is the capacitor. Capacitor is connected with any device uh, parallelly. Okay, so see when okay, first of all we have to connect a switch. Okay, now when we switch off the circuit, then it will get slowly switch off. Like see, slowly light goes off because many of components uh, if we switch off directly, suddenly switch off them, then it will damage the components slowly. It means after some time it will get damaged. So that's why we use capacitor for protecting them to sudden switch off. When we power on, the capacitor stores some voltage, and when the power off, when we will cut the power supply, then capacitor will provide some energy to the LED so that it will slowly switch off. So it will increase the life of device. So we will use the capacitor for mainly for that purpose. So move to the next part, the inductor. Inductor is also used for the same concept, to protect the device from the current, sudden change of current. Capacitor is protecting the device from uh, sudden change of sudden switch of the component, but inductor is used for sudden change of current. Inductor, I think inductor is, yeah, this is inductor. So we can see in our house the uh, actually the voltage and current is almost every time changed. So the speed of fan is increasing and decreasing, light is increasing and decreasing. So for protecting from the sudden change of that current, we will use the inductor. So let's see, when we will switch off it, it is slowly, okay, it will show some error here. Actually this is the error, this is bug from this site, this website. Okay, when we will power off the, cut the power supply, then how can it light LED, how will glow LED? Okay, so it is the bug I have used before, and same thing happened. Okay, so basically it is used for the sudden change of current. When we will increase the current, it will protect the device from the current. Okay, move to the next part. Yeah, breadboard, it is the main component we will use for any project. Like we have to connect so many components to the same circuit, then we will get confused by these connections. So that's why we will use a breadboard. Okay, so here are three type of breadboard. It is bigger, medium and a smaller. So we can use the bigger, remove the all connections. Okay, so we will, in breadboard we will give the power supply to this terminal. It means the side row of the breadboard, both side of. So we can give to the positive supply to the any row, like we can give the negative to that row, and we can give to the positive supply to that row. Now the whole
Hello,
row.
Manish Bhaiya. Uh, like we can ask if everyone are comfortable in Hindi, we can proceed like Hindi plus English. So it will comfortable for you as well to like express the
Everyone
thing.
don't know Hindi, right? It's
No,
better
no.
if they tell in
Oh,
English
oh,
only.
oh, okay, okay,
Yeah, yeah.
okay. I was just confirming. Okay, no problem. Go ahead.
Okay, So we can connect the any row to the negative supply and any row to the positive supply. And now the whole row will get connected to the negative and this row will connected to the positive. And now we can take the positive supply from any of the hole. If we have practical components, we have practically physically that breadboard, we can connect any component inside the any hole. So and this this part is used for uh, connecting the components. This is for power supply and this part is for the components. So here I have connected positive to that terminal. Now the whole this is column. So now the whole column is connected to the positive of terminal. If we will remove the resistance from here, now it is not connected to the any supply. So if we will connect to the, so this is the this column to connect it to the positive supply, and we can connect LED with same column to the any hole, and now we will connect that hole to the negative. Now it is working. It is working. So if we need more LED, if we need more LED to connect, then we can connect it from it anywhere, and we can take a resistor, connect the positive terminal to the positive row and negative terminal to the negative row. Now both LED work. So like this we can use many components for that. We can use switch. So we will connect the switch here and now connect the resistor here, and we will connect that column to the middle part of the switch and the second terminal of the switch to the LED. Now see, it is also working. So we can use it for any connecting the any components, more than one components. Complex circuit can be easily done with the help of breadboard. Okay, so breadboard is basically two types. First is we can use them for connecting the components and removing the components. So basically for uh, practical experiment we can use the breadboard, and after the prototype done we can uh, do the same circuit diagram on printed circuit board for production. So at this time is breadboard is sufficient for us. Now next is ammeter and voltmeter. So ammeter and voltmeter is used for basically measuring the current and voltage. You can see. So if we need to measure the current through this terminal, then we can use ammeter. They can. So here is a, so On the Tinkercad, the individual meter is not present. So we can use multimeter. We can take multimeter and select here which one which we have to need. We can measure the resistance from that meter also. So I need to measure the current. So I have taken the amperage, and now connect to the. So basically ammeter is connected in series with any circuit. So I will connect it to the that terminal, and it connect to the that terminal. Okay, so current will flow from here through the resistor and go to the ammeter, and from the ammeter to here, and then with the through the switch, and through the switch go to the LED, and LED to the negative terminal. Circuit is completed. Now let's measure the current. So the current is 0 ampere when the circuit is off. When we will on the circuit, it will show the current 7 milliampere. And we need the maximum current through the LED is 20 milliampere. So LED is safe. It is less than 20 milliampere. Now we can measure the voltage. Select the ammeter voltage. Now for calculating the voltage, we have to connect it in parallel, not in series. So if we want voltage through the LED, then we will connect it to the connect across the LED, and then see how much voltage it will take. So LED will take 1.95 volt. So we can calculate the resistance of LED with the help of this value. We have calculated the current through it and voltage through it. So as we know, V equal to IR is Ohm's law. So from that formula we can calculate resistance of that LED. Okay, so now we will see the sensors. Okay, so basically we will learn about some sensors like infrared photodiode, LDR, thermistor, flex sensor, microphone. It can be used for many projects. So infrared sensor. The infrared sensor is basically a LED which emits the infrared. We can see the infrared sensor in our remote in our house. Every remote has an infrared sensor inside this. So infrared sensor is work with the help of infrared receiver. If we don't have infrared receiver, then it will not work. Infrared sensor. So see here infrared sensor on Tinkercad. IR sensor. This is IR sensor. So this is IR sensor, but it will work with the Arduino. Okay, so I will not explaining you Arduino about Arduino. It will explain the Ankit thing from 9 p.m. So that's why I cannot show the practical implementation of any sensor. He will explain. He will explain all the practical. Okay, so infrared sensor and infrared receiver is used for any project. Like you can see the remote control operation. The next is photodiode light sensor. So light sensor, it is uh, it is all used for the infrared receiver. Okay, when we will uh, provide the infrared rays on that, it will give some output. So we will detect the infrared and uh, use them as according to uh, as we want any operation after detecting the infrared. And this is the IR sensor, uh, the whole connection of the infrared emitter and infrared receiver. So it is used for yeah. So it is used for uh, any project. It is easily used. It can be. It has 3 terminal, so that's why it can be easy to use, and we mainly use that device for any project, because in that part we have uh, both the sensors separately, and we have to connect it. Um, it has many complex circuit. Yeah.
Yes. So I was asking, does every remote use this infrared sensor and infrared diode LED?
Yeah, maximum remote control use that.
So let's say I have both AC remote and a TV remote. So if I
Yeah,
am, let's say, sending some instruction to my AC,
yeah,
will that turn on my TV, or even like what I am saying? Will that
yeah, yeah,
affect?
yeah,
Will that affect that? Because I think this is the limitation, that any infrared will can affect your device, may change it or
yeah,
anything.
yeah.
Yeah.
Actually, okay, I am explaining. Actually, remote has many buttons. So how can a receiver detect the right button? We will press the volume up button, then volume up operation will be performed. So it has some frequency. When light infrared LED light emits, then it emits in some frequency, and receiver will detect that frequency, and uh,
Okay.
and um, perform the same task as the infrared receiver infrared ray emits. Okay,
Yeah. Got it.
so for any operation, it has uh, a different frequency.
Okay.
Okay, so that's why we will use we have used this type of infrared sensor for easy operation. Okay, it can be used for Automatic system like lamps, taps, burglar alarm, radiation thermometer, night vision cameras, etc. Next is PIR sensor, passive infrared sensor. These are used to detect the motion of humans, animals, and things. It will work basically with the motion of humans. So it is also known as motion sensor. Okay, it detects the motion of any human, animal, yeah, any object. As we have seen, infrared sensor work in only in a straight path. It will not detect the signal from other sides. Okay. Like remote is only working if we will focus it on the focus it on same direction, then it will work. But passive infrared sensor will work for some range of angle. Exactly I don't know, but it will work for 120-degree approx. Okay, passive infrared sensor. It is used for automatic light. Like if we enter in house, the light automatically lights up. Uh, Sir Samir, can you elaborate about your problem?
No, no. I was just asking that is it like line of sight? What uses line of sight? Like it says that in networks, one tower sends to other tower. It uses a line of sight, something like there should be no object between, like no it should there should be no horizon touching between those towers. I read it in, I guess, in class 12th physics,
Yeah.
line of sight thing in communications chapter. Yeah. So that's what I
Okay.
was asking.
Okay. Okay. So PI sensor, we can use it. We can use it for automatic doors. Like if anyone is near the door will automatically open. Okay, staircases, it means when no one is there, then it will uh, turn off, and when anyone uh, will come near to the device, then it will turn on. The next is light emitting, light dependent diode. Okay, sorry. The next is light dependent resistor. Light dependent resistor is basically a register, okay, which uh, which show some value light when light will reflect on it. You can see it in any light controlled street light. Okay, when the uh, sunlight detects when the LDR detect the sunlight, it will turn off the street light. So we can use in that like same project for a light LDR. Okay, next is thermistor temperature sensor. Temperature sensor is used for sensing the temperature, like room temperature or any other environmental temperature. It will used for electric iron, washing machine, toaster, coffee machine, etc. Electric iron. Today we have many electric irons are automatically turn off. For if we will set some value, it will automatically turn off after the desired temperature reached. And if the temperature, so temperature sensor is used for that. Next is flex sensor. Flex sensor, it will mainly increase the value when we will bend it, and it is used for sensing gloves, joysticks, etc. Like sensing gloves, it means when we will bend the finger, the sensor also will bend, and it will increase the value of resistance, and we will perform any task by the value of resistance. If we will, if the sensor is a straight, it has some value, and when we will start bending it, it will uh, like increase the value of resistance, and we can use that for any other tasks. And next is microphone. So microphone, we can also say it sound sensor. It will detect the audio signal and convert it to the small millivoltage electrical signal. So when it detects any sound, it send the electrical signal to the device, and we can perform the similar task by the sound. So it is used in phone, sound sensing device, microphone, etc. We can use it in any project, like if uh, we can send any sound signal. Then if we want a light with sound, operating with sound, then when we will give the sound signal, light automatically on. So we can use that sensor. Ultrasonic sensor. Ultrasonic sensor is used for calculating the distance. So it has uh, two sensors. First is transmitter and second is receiver. It will basically transmit the ultrasonic sound, ultrasonic ray. Okay, so it ultrasonic ray will emit from the first sensor, and it will go in a straight path, and it reflect with any object, and then back to the receiver, and receiver will detect the ultrasonic ray, and it will sense the distance of that object. That object will reflect the that any object will come to the ultrasonic ray, then it will reflect the ultrasonic ray to the receiver, and it will detect the distance of that object. So it will used for any robots, level detection, drones, etc. Like any robot is moving, and uh, a wall in front of that robot, then it will detect the distance of wall, and it will change his path the according to the instruction given to them. Next is gas sensor. Gas sensor is used for detecting the gas leakage. So in industry, many different type of gas sensor is used, and all have different operations. Many gas sensor have detect some other gas, some different gas. So we have to select the perfect gas sensor for any project. Like which gas sensor is used for our project, we have to select it. So it is mostly used in industries for safety. Like many industry use gases for their operations. So they will use gas sensor for protecting the gas leakage, protecting from gas leakage. Gas sensor is also used for air quality detection. Okay, so the sensor part is covered, and the practical implementation will take the Ankit Singh from the 9 p.m. So if anyone have any doubt, please ask. If anyone want more practical on Tinkercad, then I can show. Anyone have any doubt on Tinkercad? Okay, we can perform basics operation here, like this is the LED operation. This is the potentiometer operation, switch operation, multiple LED, DC motor, DC motor. Okay, the DC motor is operating with LDR sensor, light dependent sensor. Okay, when we will provide light, it will operate. So basically it has very less resistance. So no, it has more high value of resistance. So that's why the motor is operating slowly. But when we increase the light, the motor will start increases its speed, because the value of resistance will decrease with the light. If we increase more, if we will increase more light, then motor then in higher speed. So light dependent resistor is used for many light dependent operations. So if we need to uh, turn off the motor completely by this resistor, so we can add here a resistor. We can add here is register. Because the resistance of LDR is not sufficient to turn off the motor. So we have increased the resistance, the value of resistance. It is more greater. Now start simulating. It will also work. Actually, it is software, so that's why it has many bugs. In practically, it will turn off in that much value, but it will not turn off. Okay, so understand the operation mainly. It has many bugs. So when we will increase the resistance with the LDR, then it will completely turn off the device. Yeah. Yeah, Shivani asked.
Does the light motor has an application in different devices that we have seen nowadays?
Motor. You want to say motor?
Light motor that you have just shown in the example.
Uh, yeah, we can use motor in automatic door.
Okay. Okay. Thank you.
Yeah. So when we will increase the resistance value, then motor will start speeding up. Okay, so we can use the sensor for operating different device with the light. Okay, anyone? Okay, main practical part is we'll take the Ankit Singh. Okay, so you all have to come uh, from 9 p.m.
Sir, can we get the recording of the lecture and the PPT?
Yeah, we will provide all the things.
Thank you.
You will get till tomorrow morning.
Thank you, sir.
Okay, so now please come at the 9 p.m. That time we have the main part which was taken by Ankit Singh, and it will on Arduino. Basically, the basics of Arduino and its programming and all the practical part of with the sensors. Okay. So thank you all. Thank you for joining. If anyone has any doubt, please ask.
Hello.
Yeah.
Hello. Sir, may I ask you what is the criteria to choose the winner for this competition?
Criteria, Asis will explain. Asis?
So can you repeat your question?
Sir, what is the criteria for the winner?
For the
Winner.
okay, winner. So basically, there will be 10 teams selected first round. The criteria will be simple as we will check your solutions, codes, all the circuits, and from 10 teams you will get a chance to those 10 teams will get a chance to present their solution to the judges. Okay, on that will be on 15th, I guess, na, Manish?
Yeah.
Yeah, on 15th you will present your solution to the judges, and judges will decide the top three positions.
So when will the 10 teams compete? Like first round, when will it be done?
Yeah, it will be on 13. We will give you the problem statements. You can choose one statement and start working on it. And 14th, you have to submit your solution.
At least one solution we need to submit,
Yeah,
or
you
all
can.
the
There
solutions.
will be, yeah, there will be a lot of question and the lot of problem statements. You can choose any one
Okay,
of them.
thank you. Okay,
And also, you can work in a team of maximum 5 people, or individually. You can also do it.
okay. Thank you, sir.
Yeah, sure. Yes, Ivani, go on. How do we? So you can simply ask in the group, Telegram group, if there is anyone who is interested in teaming up with you. Uh, you can contact to them. Otherwise, you can also participate individually. In the Telegram group, there are a lot of people who are interested also in making groups, so you can contact them. Have you joined the Telegram group now? So there's also mail you. Yeah, yeah. You can join from the link in the chat box. Okay. Any other question? So okay. So I'm guessing that there is no question. So thank you all again for joining the session. You can take a break. We will start the session 2 from 9 p.m. So we can close the session now. Okay, thanks.